All right, we are group 10 and this is our final presentation. So we created a competition with group 8 and you can see group 10 on the left and group 8 on the right. And our competition was to follow a line, pick up an object at the end, turn around and bring it back to the start. So, and then you can see on the right of the slide, that was the path we followed. And each group designed their own robot. We each designed them a little bit differently. And then with the competition, group 10 ended up having the faster robot. So our design included an ultrasonic distance sensor, 5 line sensors, a servo, H-bridge, and some motors. And the ultra distance sensor sensed when the robot reached the object. The line sensors helped the robot stay on the line. Servo picked up the object, and then the H-bridge helped control the motors. And here you can see a couple pictures of our robot. On the bottom picture, you can see where the wheels are connected to the motors. And then in the top right photo, you can see the front of our robot with the distance sensor and line sensors. And then on the left photo, you can see where the servo is, the Arduino breadboard, and the battery pack.
So here's kind of our overall program flow chart. We start with the setup, declare constants and variables, and then we set the direction of the motors to forward. And that's where we start the main loop. So for the main loop, the kind of the overall idea is drive on the line until the object's detected, pick up the object, turn around, and follow the line back to the start of the course. So a little more detailed, for once the object is detected, the program stops the motors, it activates the servo to lift the object, and then it switches the directions of the motors to perform a U-turn. And then it starts performing the U-turn and then has a short delay until the sensors are off the line. Then it starts reading the sensors again. Once the sensors return to the line, it stops the motors again and sets the motors, their directions back to forward so that I can follow the line back to the start. So for the actual steering and control of the robot, we implemented a simple PID control. Our 5 sensors on the front gave us 9 possible error values from -4 to +4, with 0 being in the middle. So what the program would do is read the distance sensors, determine the error value, add the proportional gain multiplied by the error value to the derivative gain multiplied by the error value. And it would take that value and add it to the motor speed on one side and subtract it from the motor speed on the other side, depending on which side of the line the robot was veering off of.
Like Austin mentioned with the PID control, we ended up with our design having 5 sensors. The reason we made the switch to 5 is that we originally started with 3. However, the robot's path just oscillated around the line too much, and it would end up just driving itself off the line fairly often. So with our 5 line sensors and the PID system that Austin mentioned, it was able to follow the line more consistently and smoothly, and overall improve the performance of the robot. Fortunately, we didn't have to make such drastic changes with the servo motor and distance sensor. Thanks to labs that we had in the past, we were able to implement those fairly quickly, and they were able to do their job. So the bulk of the time was spent mostly on the line following aspect. And then with having the robot rotate around, we had a little bit of struggle having it find the right spot, but luckily, like Austin again mentioned, we were able to have it so that when the line sensors found the line, it would be able to continue along the path once again. So some of the lessons we learned, one of the big ones was the PID control was something that I had never used before in labs before. So it was really, really exciting and interesting to learn about the way of just with utilizing the array and setting the errors up to allow for a more dynamic system for line following. And the class and labs that we'd had, specifically lab 6 and the ones that we had to use motors, really just gave us a strong starting point for creating the robot, as a lot of the code we'd already had experience with. And so it became the problem became putting it all together, which was a lot easier than if we had to start from scratch. And again, like I mentioned with the line sensors, we learned a lot about the PID control and just how much of a difference the extra 2 sensors end up making in the end. So thank you for coming to our presentation on Group 8 versus Group 10.